This is an example of a volume-volume problem from stoichiometry. What we've got ammonia being produced by the reaction of nitrogen and hydrogen. And the question is, what volume of hydrogen is needed to produce 8.50 liters of ammonia gas at standard temperature and pressure? First thing we always need to do with stoichiometry is to get a balanced equation. So we've got a reaction up here, and we just need to balance it. And to do that, we probably need a 3 here and a 2 here, and I think that'll do it. So at this point, we can go ahead and move forward with the problem. We're going to use guess method. So we're going to start by writing out our given, which is right here. We're trying to produce 8.50 liters of ammonia gas. Our unknown is volume of hydrogen. And then STP will allow us to use 1 mole of anything is equal to 22.4 liters of that anything, or in other words, molar volume. Before we go ahead and get going on the problem, let's get a little plan going here. We can use our mole road. We know that we've got ammonia, that's our given, and we're trying to get to liters of hydrogen, so that's our unknown. So we're going to follow this path here. We're going to go from volume of nitrogen, or excuse me, of ammonia. We're going to go up and convert that to moles, again using 22.4 liters. Then we're going to go from moles of ammonia to moles of hydrogen using that molar ratio that we're going to get from our balanced equation. And then we're going to convert from moles of hydrogen to volume of hydrogen, again using 22.4 liters. So our path is going to look something like this. We're going to go from liters of ammonia to moles of ammonia to moles of hydrogen to liters of hydrogen. That's our plan. Again, some of the things that we're going to use along the way, we're going to use molar volume here. We're going to use the molar ratio here. And we're going to use molar volume again here. All right, so let's go ahead and set this up. 8.50 liters of ammonia times, I need to cancel liters, so 22.4 liters goes on the bottom. 1 mole, because it's molar volume, goes on the top. So at this point, I've canceled my liters of ammonia, and now I'm ready to go to moles of hydrogen from moles of ammonia. The way I'm going to do this is I'm going to use my balanced equation to come up with a molar ratio. So I boxed in the two things that I'm interested in. My coefficient, 2 moles of ammonia goes on top, so I can cancel moles of ammonia. I'm trying to get to moles of hydrogen, so that coefficient, 3 moles of hydrogen, hydrogen goes on top, and again I can cancel my moles of ammonia, and I'm left with moles of hydrogen. I am now at this point here, so I want to take my final step. I'm going to go from moles of hydrogen, so I'm going to get moles of hydrogen to cancel, and I'm going to use 22.4, that molar volume again, liters of hydrogen on top. My moles of hydrogen cancel. I'm left with liters of hydrogen. Now, before I go ahead and grab my calculator, let's take a look at something else. I've got 22.4 on top, 22.4 on the bottom. So those guys cancel out 2, and I'm left with just 8.5 times 3 divided by 2. I wonder if I can do this without a calculator. 8.5 times 3 is going to be 24, 25, and 8. You know what? I'm just going to grab a calculator. It's 25.5 divided by 2, which is going to be like 12.75, I think, but I just want to be sure. So I'm going to confirm this with my calculator. Hey. Oh, there we go. So I've got 8.50 times 3, hit enter, that's 25.5, yeah, divided by 2, enter. Yep, 12.75. Now with 3 sig figs, right, 3 sig figs in my answer, because this got 3 sig figs, infinite, 3, infinite, infinite, 3, infinite. 3 is the smallest number of sig figs, so this would be 12.8 using sig figs properly. So 12.8 liters of hydrogen is required to produce 8.5 liters of ammonia gas at standard temperature and pressure.